7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage UAP. Décollage. La propulsion est nominale.
And we are off. Galaxy 30, Mission Extension Vehicle 2 and BSAT-4b have started their journey. He's telling us that the trajectory is normal. And we've broken the sound barrier, Damien.
Exactly, we are now traveling faster than the speed of sound, which is equal roughly to 1,200 km per hour, and the speed will continue to increase in the coming seconds.
And look at that, Ariane 5 is blazing a trail across the night skies at the Guyana Space Center, heading out over the Atlantic. Everything's going according to plan. Right now, we are using the boosters to get us away from the gravity of our Earth, aren't we? They're doing all the work.
Yes, they are doing most of the job because they provide roughly 90% of the thrust today. It is equivalent to 13 jet engines for each boosters, and their job is really to push us away from ground and to provide sufficient velocity to the launcher. And we need a lot of energy to do that. Each booster burns 2 tons of propellant per second.
That's an awful lot. And if you look at the right-hand side of the screen, what you could see there was our distance from the pad. You could see our speed or velocity and our altitude, and you'll see it again in a minute. We can see the trajectory, which is the planned trajectory. There it is on the right-hand side of the screen now. Planned trajectory, and the white cross is the actual position of our launch vehicle. He's telling us that everything's going normally, and at the top of the screen there you can see our flight path. We are now losing the boosters. They have done their job, they've burnt their propellant, we don't need them anymore. The lighter we are, the faster we go. And if you look at the front, the top of the vehicle, that section containing the satellites, we call it the fairing. What's its job?
Its job is to protect the satellites from the outer world. First at liftoff, because the liftoff generates a lot of noise, so it protects the satellite from this noise. And during the atmospheric flight, it protects the satellite from the friction with the atmosphere, which we call the aerothermal flux.
If you look at our altitude, you can see we're 100 kilometers above our planet. That means we've crossed the border with space, often known as the Kármán line. Getting closer now to being able to eject our fairing. That's what it looks like, because we don't need it anymore, Damien. We're in space.
Exactly. The effect of the atmosphere is now very low.
So we don't have enough thickness in the atmosphere for friction to bother us, and we can see our satellites for the first time. At the front there you can see Galaxy 30 and MEV-2, and then there's a black structure that's called the cylinder, and inside that is BSAT-4b. You can't see it right now, but hopefully we'll see that later. You're getting information in your ear, aren't you? The range operations manager's hearing it, and you're hearing it too.
Yes, I have a direct link with people located near the launch pad. They are located in Galio, a few kilometers away, and they receive directly the telemetry from the launcher and gave all the confirmation and all the status, and the range manager receives exactly the same information.
And at the Space Center, the range operations manager is responsible for calling that out to everybody. Our flight path takes us out across the Atlantic. We're traveling along the equator. We have a number of tracking stations along that flight path, and they pick up the signal. You can see our flight path there. They pick up the signal from the launcher as it flies over. Is that right?
Exactly, and we have a network of stations which are located all over the flight path. The first one is located in Gallio, which is a few kilometers away from the launch pad. It will cover all the beginning of the flight up to the main stage flight. We have then Natal, located in Brazil, which will cover part of the main stage flight. And then we have the next station, which is called Ascension, which is located in the South Atlantic. And we have a gap, what we call a telemetry gap between Natal and Ascension. It means that we have a loss in the visibility, but this is completely nominal because we foresee it, and we do not lose the data because we record them in the onboard memory, and we download them when we are back in visibility. The next station is Libreville, and we have exactly the same phenomenon between Libreville and Ascension, where we have a telemetry gap, which is exactly nominal. And at the end, we will be in direct visibility of Malindi, which is located in Kenya. And Malindi will allow us to follow the end of the flight, and in particular, the ballistic phase, where we will have the separation of all our passengers.
Thanks very much indeed for talking us through that, Damien. So that's the last station you can see there on the film, Malindi in Kenya, and the guys and girls there will be tracking the separations. Joining us now in the studio is Raphael Chevrier. Raphael is a business developer at Ariane Space. Thanks very much indeed for being with us, Raphael. That means part of your job is very much looking to the future, thinking about future technologies and innovation.
Yeah, absolutely. And actually, if you think about it, only 6 decades ago, we've been launching the first spacecraft in space. And in the meantime, we've been sending humans on the moon, spacecraft on Mars, on asteroids and beyond. And so a lot has happened in 6 decades. And today we are launching satellites for telecommunication, internet, navigation, Earth observation. So you can see that space is really part of our daily lives. And that's very evolving a lot.
Absolutely. And the people who are making that happen are there right now. We're looking at various important people there in the Guyana Space Centre. Who are they and what are they doing?
Here we can see the people from ESA, the European Space Agency, and these people are currently monitoring the overall status of the launcher to check that it was inside the qualified domain. So here we see the head of the ESA office in Kourou.
All these teams very important, getting the scheduled moment here for the acquisition of the signal, picking up the signal at the tracking station in Natal in Brazil, one of those tracking stations that you mentioned to us back there, and we have the confirmation there from the range operations manager that we've picked up that signal. Raphael, and he's telling us, just a translation for everybody, that everything on board is going according to plan. Raphael, given that the launcher operates remotely, why is it important for us to have the tracking stations?
Well, it's very important for, I would say, 2 main reasons. The first one is safety. It's always safety first when it comes to launch satellites in space. So you really need to make sure that you have visibility of over the whole launch sequence, and especially in dynamic phase of the launcher. And so, you really need to know how to react if something happens. And then the second is you collect data, and then you can know more about your launcher for the next launch.
And we have separation there of the main stage and ignition of the upper stage. This is very much now the next phase of our journey. And the range operations manager has confirmed that we have the upper stage engine switched on. The upper stage is a very important piece of kit. Its job is to deliver our satellites into space. Damien, whereabouts has it got to take them?
Exactly. It will deliver our customers to an orbit that we call a geotransfer orbit. The geotransfer orbit is particular in the sense that it is elliptical, so it's like a shape of an egg. You have the short part, which we call the perigee, which is located close to the Earth, if we have an ellipse. And the highest altitude point, which we call the apogee, is the apogee of the geo-orbit, which is 35,786 kilometers. And this orbit is really important for our customers.
Yeah, I mean, geo-orbit has been used intensively to launch telecommunications satellites mainly. And it's very also important because the satellite stays on the fixed point is like following the rotation of the Earth. It's like when you are like holding your child's hand on a roundabout, then you're staying at the same position with respect to your child when your child is turning around. So it's very important that you can deliver services daily, like 20 hours a day.
And right now we're looking at a replay. This was 10 minutes and 28 seconds ago. We lifted off from the pad at 7:04 French Guiana time. That's what it looked like. It was a really beautiful launch. It was incredibly impressive. I always feel a bit sorry for these guys because they have to watch the launches on screens, whether you're in mission control or whether you're in launch control. Have you seen launches in real life?
I had this opportunity once, so it was really impressive. This is a moment that I will always remember because you are impressed first by the power, because you really feel the power of the launch, and then you see the light, which is really impressive, and the noise generated by the launcher. So even if you know how it will work, nevertheless, you are impressed when you leave it alive, and this is really something that you will remember for years. And I guess it was the same also for you, Raphael.
Yeah, it was pretty much the same. Like I remember the bright light and the sound coming from the ground. That was very impressive. And I also remember that I was really hesitating between like taking pictures with my phone or leaving the moment. And I quickly put my phone back to my pocket and lived the moment because like the images are like just breathless, really.
Yeah, it's a really exciting thing, and you actually feel the vibrations as well, which is quite impressive, isn't it? And of course, Ariane 5 is the biggest of the family of launches here. She's incredibly big, and Raphael, today she's more efficient than ever. Just very, very briefly, tell us why.
Yeah, it gained over the years, 2016, 300 kilograms of performance. So DNA is part of innovation is part of our DNA, and we continuously improve the performance for the customer's benefit.
Absolutely. Let's go and watch a film now and see what those improvements involve.
Well, for the Ariane 5 performance increase, we've introduced the so-called Performance Increase Competitiveness program, which is mainly addressing two axes. The first one is elongating the tanks to put more propellant inside. This is in the ESC part. But secondly, we were elongating the equipment bay, the VE-BH, to enable much more payload inside the Ariane, and introducing also a more innovative membrane, which will also be used in the future in the Ariane 6. Soon as we finished PIC, we had to start with PIC because the market was demanding much more performance. It was basically increasing the space below the CILDA, the so-called double seat adapter, increasing the space in the cone, and last but not least, lowering the apogee to also serve the sub-GTO. With all these measures, we gained additional 500 kilograms of performance. The philosophy for Ariane 6 is a totally different one to Ariane 5. Of course, we build up on our heritage of the Ariane family, but for Ariane 6 we use the modular design from scratch to make it versatile and scalable for all customers and the fast evolving market. Among all the different things we have at stock, I would like to mention Icarus, our innovative carbon Ariane upper stage, fully made for performance jumps into orbits which we have not visited yet. For example, the cis lunar orbit, and these are topics which we have in our pipeline. Thanks to all of our good engineers, our excellent teams which make it happen. Thank you to all of them.
Well, now during that film we picked
Tous les
up the
paramètres à
signal.
bord sont normaux.
We've heard from the range operations manager. They're telling us that everything's going normally on board. We've picked up the signal
From Ascension again.
from the tracking station in Ascension Island, which is in the middle of the Atlantic Ocean. Damien, how does... Well, I was going to ask you, how does Ariane know about where she's going, but we're going to watch a film about the vehicle equipment bay.
Embedded software. What is the biggest challenge for developers? What exactly is embedded software? It's the brain of the launcher. It is set for each flight and allows the rocket to navigate independently once the engines have been started. All the phases of the mission are programmed within it. It controls the smooth progress of the flight and is ready for any events that may occur. It reacts accordingly and adjusts the launcher's actions in real time. It is placed in the equipment bay right at the top of the launcher. It usually takes between 5 and 10 years and a team of 100 people to develop it. Just to recap, the embedded software is able to send a 750-ton rocket into space to analyze and respond to all eventualities, and all this with complete autonomy. Not bad, is it? But that's not all. Once in space, the launcher and its software are no longer protected by the Earth's magnetic field. Without adequate protection, solar radiation would damage them. So the engineers have designed dedicated electronic circuits to withstand this extremely hostile environment. And that's how you fly a rocket into space, through solar radiation, at 8,000 kilometers per hour.
Well, when you see such an extraordinary advanced technology, it's no wonder that people from all over the world watch our launches. And we've been asking you to write
La
in on
propulsion
social
est
media.
nominale. Tous les paramètres à bord sont normaux.
Everything's going well. To write in and ask us your questions. And the guys here have done a little triage and picked out a few questions. I'm going to start with you, Damien. A lot of people have asked us about the new rocket which is being built, Ariane 6, and a lot of people are really keen to know, will she be able to carry people?
Well, the first step, of course, is reliability, because if you want to carry people, you need a very reliable launcher. And reliability has always been of utmost importance for Ariane family of launchers. It was the case, of course, for Ariane 4, and then in Ariane 5 again. For Ariane 6, reliability will be, of course, a key requirement. And I would like also to recall that for Ariane 5, at the beginning of the project, we have a project named Hermes, for which we were supposed to carry people. And this is why we have a really reliable, redundant launchers in terms of reliability.
Yeah, and Europe also developed pressurized modules. So I agree with you, Damien, that Europe has everything needed to do that. The experience, the technology, and as a matter of fact, this market is getting stronger and stronger. I mean, right now, astronauts are going to the International Space Stations. Tomorrow they will go to the moon very often. And we know that our European astronauts take off from Russian launchers, tomorrow maybe, probably from American launchers, but just imagine what the emotion it would be to see a European astronaut taking off from Kourou. That would be just amazing.
It would be fantastic, wouldn't it? It would be really wonderful. Just a quick note to say that we've picked up the signal at the tracking station, the Libreville tracking station, which is on the west coast of Africa. Now, our first passengers to be released are Galaxy 30 and MEV-2 for Intelsat.
Le pilotage est calme. Tous les paramètres à bord sont normaux.
It's a pleasure to be with you today to celebrate the launch of our newest satellite, Galaxy 30. I want to start by thanking two long-standing partners for their ongoing commitment to Intelsat's success. Ariane Space, with our 62nd launch together today, and Northrop Grumman, which has manufactured 11 Intelsat satellites. It's an especially exciting launch day for us at Intelsat because Galaxy 30 shares a ride to space with Northrop Grumman's second mission extension vehicle. Our Intelsat 1002 satellite will be the very first customer of MEV-2 services next year. We were proud to partner with Northrop Grumman on their historic MEV Geo Orbit Servicing mission earlier this year, and we look forward to pioneering this second mission with them. Thank you to the Intelsat planning, engineering, and operations team who have been passionately involved in the Galaxy 30 and MEV-2 programs. There's also a deeper purpose and significance to these launches. Every new Intelsat satellite in space means that we're able to connect even more communities, businesses, and governments, and in turn, to empower even more people with life-changing connectivity and communication services. Galaxy 30 is Intelsat's first satellite to utilize 4 frequency bands, with C, Ka, Ku, and L-band services. It will play a key role as part of our C-band cable distribution neighborhood in the United States. It will also serve network, enterprise, and government customers with its extensive coverage of North America, including a hosted payload for the Federal Aviation Administration in conjunction with our partner Leidos. Thank you, enjoy today's launch, and go Galaxy 30 and MEV-2.
Every satellite launch is important for us. Our satellites are our assets in the sky. This particular launch replaces one of our very key video neighborhoods for our media customers over North America.
My name is Pascal Fromont. I'm the Director for Product Management of our Media Business Unit here at Intelsat.
Galaxy 30 will be there to enable this richer, higher quality content to reach the viewers and to keep entertainment, news, and sports reaching homes at its best quality in a way that is hyper reliable, always on air, ready to be consumed.
This launch is not a typical launch. Since the launch of our first satellite back in April 1965, so that's 55 years ago, Intelsat has launched 150 satellites. This is the 151st satellite that we launched. But it's actually the very first satellite that has 4 different frequency bands. It will enable a slew of new applications. It really takes a village to design, build, test, launch, and then operate the communication satellites.
It's really amazing how we pull together these different organizations with a common goal. We all really enjoy this kind of work. We get on the console at launch minus 10 hours. And once they ignite those solid rocket motors, it's 100% commitment. So you go through this wave of anticipation, worry, calm, and then relief. And then we open the champagne at the end when it's successful here in French Guiana.
We're here with a mission. We're here to connect people around the world. It's really a very inspiring business to work in.
Galaxy 30 and MEV-2 are the 22nd and 23rd satellites that Ariane Space is orbiting for Intelsat. Pretty impressive. We are coming up to the acquisition time for the tracking station in Malindi. So wait. Okay, we have that tracking station. So they're now following our launcher. Back to our questions from our viewers. Raphael, Lucy has asked us, is Europe planning any missions to the moon or Mars?
Well, I will start with Mars because it's a very good timing to ask these questions, because 2 weeks ago, as you probably know, there is this Perseverance spacecraft developed by NASA and took off from the US. It's going to Mars, it's going to the surface, it's going to grab samples there. And 6 years after that, in 2026, there is another spacecraft developed by Europe, which will take off, go there, grab the samples in orbit, in the Mars orbit, and bring it back to Earth, and it's going to be in 10 years from now. So this is a good example of long-term cooperation in space.
Yeah, no, it is, and it's incredibly exciting, and these are really inspirational and wonderful missions, aren't they? So we have another question, actually, the same one for you, Rafael, because Juanita, is quite a related question, has asked us, are you working with other space agencies like NASA, for example?
Oh, absolutely. I mean, we are working, like Europe is working with almost all national space agencies in the world. And, well, talking about NASA, just to give you an example, next year, Ariane 5 will launch a very important project. This is the James Webb Space Telescope. A lot of people are waiting for this to be in space. It's going to go at 1.5 million kilometers from here, and it's going to observe the deep space, for example, stars or galaxies that have been formed right after the Big Bang. So it's a very major project. There are many, many more projects that are made in cooperation.
That's incredible. This is going to be giving us even more remarkable information than James Webb. So that's very, very, very exciting.
And we have a lot of pressure on our shoulder on this.
Sorry, I meant even more information than Hubble. I meant to say, yes. Of course. So this is the scheduled upper stage cut-off time for our engine of our upper stage. So we are on altitude and at the right speed, and we are now going into the ballistic phase, Damien?
Yes, we have a nominal confirmation for the shutdown of the upper stage engine.
So that's good to know. Ballistic phase means that we're travelling without propulsion. We're cruising without the engine, and we're entering into the next phase now. Just very briefly, let's go back to some of our questions, because somebody wanted to ask, Wesley actually has asked, Damien, this is one for you. What advice would you give to young people wanting to get into the space business?
Well, first, you don't have to be part of the space business or being part of our domains today to join the space community. Because if you are working as a computer scientist, as a manufacturing engineer, electrical engineer, orbital mechanics engineer, structural engineer, whatever, we need all types of engineers and technicians to work. And we have several places where people can join the space community. We have industries like Ariane Group, we have Ariane Space like for launch service provider, and we have also the space agencies, CNES for the French space agency, ESA, and we have also international space agency where we can work if we need.
Yeah, and space is not just about engineers. There are lots of jobs in space. Commercial, communication, lawyers, and etc. But one thing is certain is that when you join the space sector, you become very quickly part of the family and very quickly passionate about space.
And this is indeed one big family. We can see here at the Guyana Space Center. Who are we looking at, Damien? Are these the Galaxy 30 teams?
Yes, we are looking at the operational team who have worked very hard in the latest day to complete the preparation of their spacecraft. And they are now waiting with eagerness the separation of their spacecraft, which will be like a birth for them, because the spacecraft will be ready and will complete its journey on its own.
And this is what it looks like up there, that berth that you talked about. This is the scheduled separation for Galaxy 30.
Séparation Galaxy 30.
And we have confirmation there from the Range Operations Manager. Galaxy 30 has now started its new life in space. It's making its way away from the mothership. There you have it, successful separation. Good news for our customers, right?
Very good news. A very good step for the customers.
And the space ballet continues, of
Yes,
course.
this was an important milestone, and the maneuvers will go on in order to prepare the separation of the next spacecraft.
So our next satellite to be released is MEV-2, and it was also supplied by Northrop Grumman for space logistics. Let's find out a little bit more.
Hi, I'm Joe Anderson, Senior Director at Northrop Grumman and Vice President of Space Logistics LLC, a Northrop Grumman company. Earlier this year, our first mission extension vehicle, MEV-1, made history when it docked with a satellite running low on fuel, the Intelsat 901. Now IS 901 is back in service thanks to our innovative technology that gives satellites a new lease on life. Our low-risk docking system keeps the customer operational and extends the lives of useful satellites. Once our services are no longer needed by the customer, the MEV is able to undock with the client satellite and continue on to our next customer. Today we are ready for the launch of our second MEV, which will perform its first docking with another Intelsat satellite, the IS-1002. On behalf of Northrop Grumman and Space Logistics, I want to thank Intelsat and Ariane for being trusted partners on this innovative mission. Finally, we have a short animation that shows the MEV-2 mission in more detail. Go Ariane and go MEV-2!
Oh, it's pretty impressive stuff, it really is, isn't it? And the first mission extension vehicle actually docked with, that was MEV-1, that was launched on board a Proton rocket in October 2019, and it docked with Intelsat 901 in February 2020, so that was this year. And I mean, it's really exciting, isn't it?
Yes, this technology is really amazing. As you have seen in the film, it combines several innovative technology. First, you have to ensure a rendezvous with the customer. To get that, you have to get close to the customer, to the spacecraft. You have to check its attitude, its angular rates, in order to be sure that you will be in a position to dock to it. And then you have to get very close to it and dock to it. So we have several very critical technologies, the rendezvous one, the docking one, and then it opens also a new business, because you open a business where you can extend the lifetime of the spacecraft, and you even can put it into another orbit. So you can imagine several types of business. And one particularity to be noted for MEV-2, which is a difference with MEV-1, is the fact that it will dock onto its customer satellite directly into the geostationary orbit and not onto the graveyard orbit, because MEV-1 was completely successful. So it will gain energy, and this is really an important milestone for this new business.
Yeah. It really makes sense if the market is still there on Earth to give an extra push for 5 years, and the satellites can deliver services for such 5 years. So it's very important. And in the next, in the future, we are hoping to see like even more advanced activities of such MEV satellites, such as satellites refueling, satellites repairing, and even like satellites deorbiting. So the satellite doesn't have to go itself to a graveyard orbit. It can ask for such a service, and that's a very, very advanced technology.
And here we can see here the teams at the Guyana Space Center. Who are we looking at here, Damien?
We are looking at the MEV-2 operational teams, who are also in charge of the Galaxy 30 in Guyana Space Centers. And they are awaiting for the separation of their spacecraft.
Which is coming in the next few seconds. And there you have it. This is the scheduled moment for the separation of MEV-2.
Séparation MEV-2.
And we can hear there, we've had the confirmation?
Yes.
So that's good news. MEV-2 is now on its orbit and separated, pushed away via springs there. And we can see the Northrop Grumman Mission Operations Center there. What are they doing? They're taking control of their satellite, aren't they?
Yes, first they have monitored the status of the spacecraft during all the launch, and now they are taking control over the spacecraft, and they will work continuously during the coming days in order to prepare the journey up to the final location for MEV-2. So it will include deploying antennas, deploying solar panels, and performing all the required maneuvers in order to get to the required positions and circularizing the orbit.
And we still have, of course, BSAT-4b attached. It's hidden at the moment underneath what we call the cylinder. I just want to go back to our questions because we've actually had somebody who asked just a quick response from you about the cylinder. Tony asked, how can the cylinder be ejected without damaging its satellite?
Okay, so to be very short, there are two major points. First, the separation system is made of 8 springs. So these springs provide energy to the part of the cylinder which is jettisoned. And when we need it, if the lower spacecraft occupies a very huge volume, we can tune the balance of the cylinder in order to avoid it from tilting during the separation. And the process lasts roughly 4 seconds.
So we've talked a lot, Raphael, a little bit previously about how things are changing in space, but you really do know the satellite markets very well, don't you? How have spacecraft been evolving recently?
Well, to make it short, basically we see many constellations of satellites in low Earth orbit dedicated to bringing internet, high-speed internet. The plan is to connect everyone and everywhere. And even like things like planes and trains and boats, moving things like this. And we also see more constellations dedicated to Earth observation. And these are very important for monitoring the climate change. And also it also serves some new digitalized sectors such as agriculture, building, rescue services, and also very small businesses such as counting empty spaces in parking lots, for example.
Oh, that's an interesting one. Very useful. So you can have a quick look on your app to see if there's an empty space. Yeah.
Why not?
But we've also seen traditionally that we've been launching a lot of geostationary satellites. Are they changing as well?
Yeah, of course. First, we see that electric propulsions, instead of chemical propulsion, sometimes tend to reduce the size and the mass of the satellites. So this is changing. These satellites are also more flexible. It means that they can deliver several services at a time, and that's also more powerful for them. This is going to be the case for the satellites that we are launching today, delivering broadcast services with unprecedented definition, so like very powerful satellites. And of course, we are hoping to see more MEV missions doing very impressive. For me, this is very futuristic, this kind of docking to a satellite and pushing it to the correct orbit for more years.
And of course, you're going to have to, you're adapting your launch vehicle to cater for these different shapes and sizes of satellites.
Of course. If the satellites are getting flexible and more diverse, then we need to be flexible as well. So the launcher needs to be able to launch satellites anywhere, in any orbit, anytime. And so with Ariane 6 and Vega-C, our next generation of launch vehicles, they will be equipped with a reignitable upper stage, allows you to bring any type of satellites anywhere. And for this, we also develop carrying structures, specific carrying structures, in order to offer ride shares, and that's very important for this.
Very, very important for these markets, and we'll be seeing a lot more of those in the future. Now, I'd like to go over to Japan, if we can, to Kiyoshi Takamatsu, who is the head of the Ariane Space Office in Japan. Kiyoshi, I think it's good morning, isn't it, rather than good evening? What time is it there?
Yes, then here it is a good morning in Tokyo. The Kuru is just on the opposite side of the Earth, so that the time difference is just 12 hours. So it's the same time than 7:44, but it is in the morning, and we are 12 hours ahead. So that we are now on the Sunday, August 16.
And where are you exactly, Kiyoshi?
Yes, and I am at the customer BSAT headquarters on the third floor. I'm at an office of the President Inoue. I will try to show him.
We can see everybody there, Kiyoshi. Looking good. Lots of
Yes,
waving. Hi, gang.
Can you see that? Yes, the gentleman, you can see is the President Inoue of the BSAT. So he's not alone. He is with the expert of the BSAT. And today is, and as you know, that's a very important milestone for the BSAT, MAXA, and the Ariane Space. And all of them, the BSAT is now the congratulation of the nominal separation of the Intelsat and G30 and MEV-2.
How many satellites has Ariane Space actually launched for Japanese operators, Kiyoshi?
We have launched the 31 satellite until now, and then soon it will be the 32. So that this is a good score. We captured about the 75% of the Japanese market. And also that BSAT is a very loyal customer for us. They have launched all 10 satellites with us, including today's BSAT-4b.
Well, let's hope, Kiyoshi, that in a few minutes' time you will be able to all drink a glass of champagne. It will be an early one, though.
Yes, then it will be a little bit early, but then today is on Sunday, so that then after Ariane complete its mission, we will do our best.
Very good. Thank you very much indeed for joining us, all of you from the BSAT offices there, and our best wishes to all of you. Thank you. So, as we know, Maxar supplied BSAT-4b. They have a very long history of expertise of building all kinds of satellites. We're going to watch a film, and that's going to be followed by an interview which I conducted a few days ago during our previous launch show. So let's find out more now about Maxar. Well, joining me now is Paul Este, who is the Vice President of Customer Relations at Maxar Technologies. Thanks very much indeed for being with us, Paul. Just give us a little bit of information about the structure that the satellite is built on.
Yes, the BSAT-4b satellite is built on our 1300 structure, which is our heritage structure. We've used it for all of our geocommunication satellites for many decades now. Whether the service is direct-to-home, such as the BSAT satellite, or it's fixed satellite services, or mobile, or including direct audio radio, which we do for SiriusXM. We also adapted the 1300 structure for a planetary mission. We are sending the structure and the spacecraft out to Psyche, which is an asteroid beyond the orbit of Mars. That'll be launching in a couple of years. And we've also adapted it for a lunar mission for the power propulsion element, which is the first element of the Gateway program, which is going to ultimately land the first woman and a man on the moon in 2024. So it's quite an adaptable, flexible, and reliable structure. And again, we've been using it for many years.
That sounds very exciting, and it sounds like you've got a lot going on. You're obviously doing a lot of work on innovation.
Yes, we are indeed doing a lot on innovation. Over the years, we've added, of course, 3D printing, as many people have. We're using innovative techniques in terms of manufacturing satellites, including augmented reality, virtual reality, and modern techniques of manufacturing like that.
Is this the first time you've worked with Japan?
No, actually, we've had Japanese customers for several decades, all the way back to NSTAR in the mid-90s. Recently, of course, we've had the BSAT customer. This is the second one we've done for them. We did BSAT-4a, this is 4b, both providing high-definition direct-to-home television for Japan, including several 8K HD TV channels, which are spectacular when you see them. And before this, earlier, about 5 years ago, we did 3 satellites for JSAT SkyPerfect.
Paul Este, thank you very much indeed for joining us, and best wishes now as we get close to separation.
Thank you very much.
So I was talking to Paul Este there a few days ago, but it's incredible. They're doing some really exciting stuff, aren't they?
I think he has summarized pretty well how space is evolving. Like we've heard moon, asteroids, Mars, 3D printing, additive manufacturing, and we've heard also reconfigurable satellites, and this is also like a game changer for the telecommunication market. Reconfigurable satellites in geostationary orbit is very important because satellites can switch from frequencies. A single satellite can do this in order to diversify the services, and they can also point at very specific locations on Earth.
And here we can see we're getting close now to the moment, the scheduled moment for separation of BSAT-4b. And this is what it looks like, the satellite being... And we have the confirmation there from the Range Operations Manager. So this is excellent news. Congratulations to everybody. Congratulations to everyone at BSAT, to everybody in Japan, and congratulations also to everybody at Intelsat. Good news indeed, Damien.
Yes, it is an important milestone to have this confirmation.
And best wishes to everybody now as they take charge of their spacecraft, because of course the teams on the ground will be taking on their roles. Happy faces all around there in the Mission Control Center, Raphael.
Yeah, I mean, this is really what makes this sector very special. Like when you see these smiles, you see that these people have been working for years on their project. An operator of satellites can book its location in space up to 7 years in advance before the launch. So the teams between all the partners and the customers are really working hands in hands for several years. But this is why you can see these kind of images, and this is very unique, I think.
And it must be a good feeling for them, Damien.
Yes, it's really a specific moment for everybody, because depending on what you have worked on, even if it's months or years, at the end of this job, you see the result of your job, and when it is a success, it is always a specific feeling. And now I would like also to thank all the teams that were involved in the launch, so the people in Guyana, of course, but also all the team all over Europe on the launcher side, and of course from our customers.
Well, and I'd like to thank everybody as well. We're going to go to a film in a second, but before we do that, I want to thank these gentlemen sitting next to me, because it's been wonderful having both of you joining me here in the studio. Thank you very much indeed, Damien Gilles.
It was a pleasure, thank you.
And thank you very much indeed, Raphaël Chevrier.
Thank you, Katie.
Thank you.
Really good.
And I hope you'll both join us again soon. We're going to go to a film now, because we are celebrating the 40th anniversary of the Ariane launches. In 4 decades, they have launched all types of spacecraft into all types of orbit. Let's find out more.
Ariane 1, the first launch vehicle designed in Europe, lifted off for the first time in December 1979. It was designed from the outset for geostationary launches. This made it perfect for the growing communications satellite market. Europe quickly capitalized on this opportunity in 1980 by founding Ariane Space, the first commercial space transport company. The first member of the Ariane family logged 11 launches between 1979 and 1986 for both government and commercial customers. With this success under its belt, ESA quickly developed Ariane 2 and 3. Ariane Space would carry out 17 missions with these 2 launches from 1982 to 1989. Ariane 3 added the ability to perform dual launches, sending 2 satellites at a time towards geostationary orbit, and this technique would quickly become the hallmark of Ariane Space. At the end of the 1980s came Ariane 4, a launcher that used the same basic design as its predecessors, but was even more capable. Because of this rocket's capabilities, Ariane Space captured fully half of the global market for commercial launches. Ariane 4 was retired in 2003, passing the baton to the newest family member, Ariane 5. Once again, the idea was to boost its power to handle increasingly hefty telecom satellites, while also maintaining the strategy of dual launches into geostationary orbit. At the same time, Ariane Space decided to expand its family by offering launches on the storied Soyuz rocket from the Guyana Space Center. This service started in 2011. Then in 2012, Ariane Space introduced a new light launch vehicle,